Hi, we are a team of University of Toronto industrial engineering students working with Professor Scott Senner and Mott MacDonald. I am Kelly.
I'm Helen.
I'm Gigi.
And I'm Joyce.
This presentation is on our COVID-19 TravelSafe navigation tool. Let's first imagine a scenario. Tomorrow, you'll be walking to U of T campus. You'll probably be worried about your personal safety against COVID. This is a growing concern. Existing tools in the market, such as Google Maps or Rocketman, lack the ability to detail COVID risk to route planning level. Hence, the Capstone team developed an aspirational tool that informs and assists users to travel safer routes. The key design concept of our tool is to plan routes based on users' preferences on risk and speed. Our target user groups are pedestrians and public transit riders. Our tool has three key requirements. First, the app should be accurate in COVID-19 infection risk estimations and total travel time estimations. Second, it should be customizable for route planning. And finally, the app should be just as intuitive as with the other popular navigation apps in nowadays market.
Through extensive research, we found the risk of infection to COVID is mainly proportional to three factors: the number of people in contact with, the duration of contact, and whether you're indoor or outdoor. The infection risk indoor has a Poisson distribution as shown in the left figure. For outdoor traveling, such as walking down the street, assume each pedestrian encounterment is short in time, the risk approximately becomes a linear function of the total pedestrian encounterment during the trip, as shown in the right figure. Literature review also suggests that under normal Toronto weather, one indoor pedestrian encounterment generates the same infection risk level as 5.52 outdoor pedestrian encounterments. Our next step is to obtain pedestrian volume of each road intersection to quantify risk. We implemented a fine-tuned YOLO V3 object detection algorithm to extract the pedestrian volume from real-time Toronto traffic surveillance camera images, as shown in the left. The scatter plot on the right shows our detected pedestrian count versus the ground truth from 100 test cases. The strong positive correlation between our detection and the actual count shows our detection is very accurate. Our object detection algorithm has a mean absolute error of 0.34, which means the detection is of much less than one person per image.
The next problem is that not all intersections have cameras, so we need to interpolate the pedestrian count data from camera locations to all locations. The team tested several machine learning techniques and found the best performing solution is the kernel density estimation method, demonstrated here. Using this method, the mean absolute error between the actual pedestrian count and the predicted pedestrian count is around 2 people. We also need to incorporate TTC ridership data for public transit risk calculation. The hourly passenger count and percentage of occupancy of different transit routes are simulated based on 2019 data we requested from the city, time of the day, and vehicle size, and is verified by our client, Mott MacDonald. The graph in box 6 shows the simulated hourly passenger count of a 51-seat bus following the 6-bay route. Our search algorithm efficiently calculates routes based on our data. We use A-star algorithm to search for routes. A-star algorithm is the same algorithm navigation tools like Google Maps implement. This algorithm is the most efficient searching algorithm and allows our tool to generate results in less than a second. While existing tools only care about time, our tool optimizes with respect to both distance and risk level. In our implementation of this searching algorithm, multiple routes are generated based on the different risk levels. More risk-averse routes will weigh the risk factor less.
So here's the web interface of our tool. And now say I want to walk to the metro science building from where I live, and I want to take less than 5 minutes touring while avoiding hospital and crowds. So I will first submit my preference to this questionnaire. And upon clicking the Finding My Routes button, the planned path will be displayed on the map. And in this case, we can see 2 walking paths I found, and we color-coded each of the passes to represent the risk level of of each path segment, which is determined by the estimated number of pedestrian encounters. And the color scheme legend will also appear on the top right corner of the map. More details will also appear in the info box if you click on the routes, and the route information including total time, estimated total pedestrian encounters, and distance are also displayed in the left sidebar. You can also navigate on traveling by public transit and see the details including navigational steps and estimated occupancy rate of the transit. Furthermore, it's also worth noticing that you can visualize the estimated risk levels throughout the city by this heat map overlay. So the team also iteratively improved the tools UI and functionalities based on users' feedback. And to test how well our tool demonstrate the trade-off between risk and time, we asked the user to rank multiple display routes based on their perception of the route risk levels and compare the results with the ground truth. Candle Talk score is used to measure this. Initially, the score was a 0.12, and we managed to increase the score to 0.68 by improving some features in the front-end display. In the survey solicited by Maud McDonald, we received 74 responses, and it showed that the user's travel concern centering COVID-19 spread has been successfully reduced by 12 times.
Clearly, COVID is impacting the way we live around in this city. Given that no other navigation tools manage to quantify risk, our team obtained data from the city's traffic cameras, applied machine learning data interpolation techniques, simulated TTC ridership data, and developed a user-friendly UI, all to assist users to plan their trips. In conclusion, safety is of paramount importance in traveling around nowadays. As there is no tool that visualizes risk in the current market, our tool not only fulfills this critical gap, but also improves the way people live around in this era of pandemic. And that ends our presentation. Thank you.